Preparing for IBM Technology Interview Questions and Answers interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. Explain the 4 pillars of object-oriented programming and how you have applied them. The 4 pillars are encapsulation, abstraction, inheritance, and polymorphism. I use encapsulation to protect state behind methods, abstraction to expose only necessary behavior, inheritance when there is a genuine as a relationship, and polymorphism to substitute implementations safely. For example, a payment processor interface can support card and bank transfer implementations without changing callers. I prefer composition over deep inheritance because it reduces coupling and makes enterprise services easier to test, extend, and maintain. While answering, define encapsulation, abstraction, inheritance, and polymorphism. Connect each to maintainability, extensibility, testing, and a practical Java or enterprise application example. Question 2. How would you optimize a slow SQL query in a production application? I start by reproducing the issue and inspecting the execution plan rather than guessing. I check for full table scans, inefficient joins, missing or unused indexes, stale statistics, and excessive rows returned. Then I rewrite predicates, select only needed columns, and add or adjust indexes based on actual access patterns. I benchmark with representative data, review write overhead, and deploy gradually. An index that speeds reads can still hurt inserts and storage. Make sure to cover execution plans, indexes, joins, filtering, returned columns, statistics, query frequency, locking, and measuring improvements safely before changing production database behavior. Question 3. How would you design a reliable REST API for an IBM enterprise application? I would model clear resources, use HTTP methods consistently, and return meaningful status codes with a stable error schema. Requests would be validated at the boundary, authenticated through the organization's identity platform, and authorized by role or policy. I would add pagination, filtering, correlation IDs, rate limits, and API versioning where compatibility requires it. For retried operations, idempotency keys prevent duplicate effects. OpenAPI documentation and contract tests keep consumers aligned. In your answer, discuss resource-oriented URLs, HTTP semantics, validation, authentication, authorization, versioning, idempotency, pagination, error contracts, observability, and backward compatibility. Question 4. When would you choose microservices over a modular monolith? I choose microservices when business boundaries are clear and teams need independent deployment, scaling, or technology choices. A modular monolith is usually better when the domain is evolving, traffic is modest, or the team lacks operational capacity. Microservices introduce network failures, distributed tracing, deployment coordination, and data consistency challenges. I would begin with strong modules, measure bottlenecks, and extract services only when a concrete boundary or scaling requirement justifies the additional complexity. Be sure to mention bounded contexts, independent deployment, team ownership, scaling needs, operational complexity, distributed transactions, observability, and the risks of prematurely splitting an application. Question 5. How would you deploy an application across IBM Cloud and on-premises infrastructure? I would package the application in containers and deploy it through OpenShift, keeping manifests and configuration environment neutral. A secure network connection would link on-premises systems with IBM Cloud, while identity federation and centralized secrets management control access. CD would promote the same tested artifact across environments. I would define data residency and recovery requirements early, then add unified logs, metrics, traces, and automated failover tests. Portability is valuable, but operational consistency matters more. Focus on hybrid cloud architecture, OpenShift portability, networking, identity, secrets, data residency, deployment automation, monitoring, disaster recovery, and minimizing environment-specific assumptions. Question 6. What is the difference between concurrency and parallelism, and where can bugs occur? Concurrency means managing multiple tasks during overlapping periods, while parallelism means executing tasks simultaneously, usually on multiple cores. Bugs appear when shared state is accessed without proper synchronization. Two threads may override updates, observe stale values, or wait forever in a deadlock. I prefer immutable data, message passing, or thread-safe collections before adding locks. When locks are necessary, I keep critical sections small, establish ordering, and test under realistic contention. Explain task interleaving versus simultaneous execution, then cover race conditions, deadlocks, visibility, atomicity, locks, immutable data, thread pools, and safe testing strategies. Question 7. How do you decide what to test at the unit, integration, and end-to-end levels? Unit tests should cover business rules quickly and in isolation. Integration tests verify database, messaging, identity, or external service behavior, while end-to-end tests validate a small number of critical user journeys. I avoid excessive mocking because it can hide integration failures, and I avoid relying entirely on slow end-to-end suites. Coverage is a signal, not the goal. I prioritize high-risk paths, regression history, boundary conditions, and clear failure diagnostics. Discuss the testing pyramid, isolation, speed, contract testing, critical workflows, mocks, production-like dependencies, failure diagnosis, and balancing coverage with meaningful risk reduction. Question 8. Describe a C/CD pipeline you would build for an enterprise Java application. A pull request would trigger compilation, formatting checks, static analysis, unit tests, dependency scanning, and integration tests. After review, the pipeline builds one immutable artifact, publishes it to a controlled repository, and deploys it through staged environments. Smoke tests and health checks gate promotion. For production, I would use blue-green or canary deployment, monitor key indicators, and support automated rollback. Every change, approval, and artifact should be traceable for enterprise governance. Make sure to include source control, build reproducibility, static analysis, unit and integration tests, dependency scanning, artifact repositories, approvals, deployment strategies, rollback, and auditability. Question 9. How would you secure an API handling sensitive enterprise data? I begin with threat modeling and classify the data, because controls should match risk. All traffic uses TLS, identities are verified through standards-based authentication, and authorization follows least privilege with explicit resource checks. Secrets stay outside source code, sensitive fields are encrypted appropriately, and inputs are validated to prevent injection. I add rate limiting, audit logging without leaking data, dependency scanning, and alerting. Security also requires rehearsed incident response and credential rotation. Cover threat modeling, TLS, identity, least privilege, input validation, secrets management, encryption, audit trails, rate limiting, privacy controls, dependency updates, and incident response. Question 10. How would you troubleshoot a production service whose response time suddenly increased? I first confirm the scope using latency percentiles, error rates, traffic, and affected endpoints. Distributed traces help separate application time from database or downstream latency, while CPU, memory, thread pools, and connection pools reveal saturation. I compare the timing with deployments, configuration changes, and traffic shifts. If customer impact is severe, I mitigate through rollback, scaling, or feature controls before investigating deeply. After recovery, I document root cause and add preventive monitoring or tests. In your answer, explain triage, dashboards, logs, traces, recent changes, saturation metrics, dependency latency, rollback decisions, customer impact, and documenting the root cause afterward. Question 11. How would you design a scalable order processing system? I would accept an order synchronously only after validating the request and assigning an ID impotency key. Durable events would then drive inventory, payment, fulfillment, and notification workflows asynchronously. Each consumer would be independently scalable and idempotent, with retries using backoff and a dead letter queue for poison messages. The order state machine must represent partial failures clearly, and reconciliation jobs should repair inconsistencies. I would measure queue lag, processing latency, failures, and business outcomes. Discuss service boundaries, synchronous versus asynchronous work, durable messaging, ID impotency, inventory consistency, retries, dead letter queues, observability, and recovery from partial failure. Question 12. What caching strategy would you use for a high-traffic IBM application? For read-heavy data, I would usually use cache aside. Check the distributed cache, load from the database on a miss, then populate it with a suitable TTL. I would define whether stale data is acceptable before choosing invalidation behavior. Hotkeys need replication or request coalescing, and cache failures must degrade safely to the database with protection against stampedes. I would monitor hit ratio, evictions, latency, and memory pressure rather than assuming caching automatically improves performance. Be sure to cover cache aside, TTLs, invalidation, consistency expectations, hotkeys, eviction, distributed caches, stampede protection, and when caching creates more risk than value. Question 13. How would you use Kafka or another event platform in a distributed system? I would publish domain events to topics organized around stable business boundaries, choosing partition keys that preserve required ordering while distributing load. Consumer groups allow independent applications to process the same event stream. I would use schema compatibility rules, explicit retention, monitoring for lag, and idempotent consumers because retries are normal. Exactly once claims require careful design across boundaries. In many systems, at least once delivery plus deduplication is simpler and more dependable. Focus on topics, partitions, ordering, consumer groups, delivery semantics, schema evolution, replay, retention, idempotent consumers, and handling failures without losing business events. Question 14. How would you modernize a COBOL or mainframe application without disrupting business operations? I would avoid a risky rewrite and first map capabilities, interfaces, data ownership, and critical transaction rules. A strangler approach can expose stable APIs around the mainframe, then gradually move independently understood capabilities to modern services. Events or controlled synchronization can support coexistence, but ownership must remain explicit to prevent conflicting updates. I would build characterization tests, compare outputs during migration, monitor performance and reconciliation, and retire components only after operational confidence is established. Mention domain discovery, strangler patterns, APIs, event integration, data synchronization, coexistence, non-functional requirements, incremental migration, testing, and protecting critical transaction behavior. Question 15. What makes a containerized application production ready on Kubernetes or OpenShift? A production container should be minimal, reproducibly built, scanned for vulnerabilities, and run as a non-root user. The deployment needs resource requests and limits, readiness and liveness probes, graceful termination, externalized configuration, and managed secrets. I would define network policies, persistent storage only when necessary, and horizontal autoscaling based on meaningful metrics. OpenShift adds strong security defaults, but the application still needs structured logs, metrics, traces, and tested rollout and rollback procedures. Cover image security, resource requests, health probes, configuration, secrets, graceful shutdown, autoscaling, network policies, persistent storage, observability, and deployment safety. Question 16. How would you evaluate an AI solution for an enterprise use case at IBM? I would begin with the business decision the model must improve, not with a fashionable algorithm. I would validate data provenance, representativeness, privacy, and labeling quality, then select metrics that reflect real costs such as false approvals or missed risks. Before production, I would test fairness, robustness, explainability, security, and human override paths. Post-deployment, drift, performance, feedback, and incidents require continuous monitoring. A smaller transparent model may be better than a complex one. In your answer, discuss business value, data quality, model accuracy, fairness, explainability, privacy, security, human oversight, monitoring, and measurable production success criteria. Question 17. How do you make a distributed service resilient to dependency failures? Every remote call needs a timeout based on the user or workflow budget, otherwise threads and connections can exhaust. I use bounded retries with jitter only for transient, safe operations, plus circuit breakers and bulkheads to contain failures. Idempotency prevents retry duplication, while fallbacks or cached responses preserve partial functionality where acceptable. Health checks should distinguish readiness from liveness. Finally, I run fault injection exercises because resilience mechanisms are credible only when tested. Discuss timeouts, bounded retries, exponential backoff, circuit breakers, bulkheads, fallbacks, health checks, idempotency, graceful degradation, and testing failure scenarios deliberately. Question 18. Which data structure would you use to detect duplicate values efficiently? I would use a hash set when I need to detect duplicates in one pass. For each value, I check whether it is already present. If so, I return a duplicate, otherwise I insert it. Expected time is O(n), and additional space is O(n). If memory is constrained and mutation is allowed, sorting gives O(n log n) time with less auxiliary space. For massive streams, I would consider partitioning or a probabilistic structure. Explain the hash set approach, expected time and space complexity, memory trade-offs, input constraints, sorting alternatives, streaming options, and how duplicate semantics affect the solution. Question 19. How do you approach designing a system for high availability and disaster recovery? I translate business requirements into an availability target, recovery point objective, and recovery time objective. Then I remove single points of failure across compute, networking, storage, and dependencies, using multiple failure domains where justified. Data replication strategy depends on consistency and recovery needs. Backups still matter for corruption and deletion. Automated failover is useful only with clear runbooks, monitoring, and regular game days. I measure recovery results instead of treating architecture diagrams as proof. Be sure to cover availability targets, redundancy, failure domains, replication, RPO, RTO, backups, failover, consistency, observability, runbooks, and regularly tested recovery procedures. Question 20. Describe a technical disagreement with a teammate and how you resolved it. In one project, a teammate preferred splitting a new capability into several services, while I favored a modular monolith. We clarified the actual scaling and ownership requirements, compared operational costs, and built a small proof of concept. The evidence showed that independent deployment was not yet valuable, so we agreed on strong module boundaries and documented extraction criteria. I supported the decision fully afterward. Good disagreement improves designs when it stays evidence-based and respectful. Focus on clarifying requirements, separating people from ideas, using evidence, evaluating trade-offs, documenting the decision, collaborating respectfully, and learning from the result afterward. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.